Welcome back, Wolfpack, to Lesson 3.6, Segment Partitions. Our essential question is, how is a segment ratio similar to a triangle ratio? Let's go ahead and get started on our vocabulary. A directed line segment is a segment that has both direction and length. It's going a specific way, and it's a specific distance. It has length. It's a vector. In a directed line segment, the order of the segment matters. A directed line segment AB has a starting point at A and moves toward B. When we partition a segment into a ratio, we need to know where the segment starts. So the word partition means to divide up. We will use slope, which is rise over run, and we'll also use scale factor, which we use the letter K to show or notate scale factor. To help us find exact coordinates for the point that partitions a directed line segment, we need to remember two things. Ratio means part to part, whereas scale factor means part to whole. You add the parts together to find the whole. So basically what we are doing is, if I said I have this line A, B, and I wanted to divide it up into 3/5, you are telling me the coordinate that divides it up. Okay, so if AB was at 5, 7, and, if A was at 5, 7, and B was at 10, 19, what is the point that divides it up into 3/5? That's what we're doing right in these problems, okay, just to put it simply. We're partitioning or dividing up a line. So, example 1, determine the ratio of each partition line segment AB. Remember, ratio is part to part. So, from A to P, I have 1, 2, 3. And then from P to B, I have 1, 2, 3, 4, 5. So my ratio is 3 to 5. Or you could say 3 to 5. Okay. Next one, we're doing A to B. And notice right here it says of line segment AB. So that means A is the starting point, B is the ending point. So we have to make sure we start at A. So from A to P, we have 2. And then from P to B, we have 1. So 2 to 1 or 2 to 1. Okay, because we have to make sure we start at the correct letter. I'm going to go ahead and pause the video and try it on your own. Try it on your own. Actually, I lied. I don't want to try. This is scale factor, which we haven't done scale factor yet. So I will do this with you. Scale factor is not ratio. Scale factor is part to whole. So it says determine the scale factor K for the partitioned directed line segment AB. Well, from A to P, how many parts is that? It's 3. From P to B, how many parts is that? It's 5. Well, scale factor is part to whole. So 3 over 3 plus 5 equals 3/8. That is our scale factor, 3/8. Okay, so ratio is part to part, which means I was showing 3 to 5, 2 to 1, but scale factor is part to whole. So from A to P was 3, but the entire line is partitioned into 8 parts, so 3 to 8. Example number 2, determine the value of K if partitioning a segment into a ratio of 1 to 5. So remember, ratio is part to part, so 1 to 5. We need part to whole. So part to part. We need part to whole. Well, the part is going to stay the same, so it's 1 to something. Okay? 1, actually I should write it as 1 over something. But then the whole is the sum of the parts, so 1 plus 5, or 1 over 6. That's our scale factor. So I kept the 1 as my part, and then I added the 1 plus 5 together, which gave me the 6. Try it. Partition segment AB into a 1:3 ratio. Okay, a 1:3 ratio. That means I'm going to draw a point P somewhere. So 1 plus 3 is 4 parts. I have to divide AB into 4 equal parts. Well, I noticed there are 1, 2, 3, 4, 5, 6, 7, 8 parts to AB. Okay? So I have to divide 8 pieces into 4 different groups. Well, 8 divided by 4 is 2. That means every 2 I'm going to have a section. And we've done something just like this before. Okay? So here's a section. Here's a section. Here's a section. Here's a section. I have 4 sections. So I need to draw my partition in a 1:3 ratio. That means right here, because I have 1 group, then I have my dividing point, and then I have 3 groups. And all my groups are equal. Okay, so my point P is right there. I partitioned my line into a ratio of 1:3. The measures of the interior angles of a triangle are in the extended ratio of 1:5:9. What are the measures of the angles? So we know that all the measures of the angles of a triangle add up to 180 degrees. So it's not 1, 5, and 9. It's 1 something to 5 something to 9 something. So we can use a variable as our replacement. So we have 1x plus 5x plus 9x equals 180. Okay, so obviously the angles are not 1, 5, 9, but they're in a ratio of 1:5:9. So if I add all that up together, I have 15x equals 180. Divide by 15, x equals 12. Okay, so I know that one angle is 1x. So 1 times 12 is 12 degrees. One angle is 5x. So 5 times 12 is 60 degrees. And one angle is 9x. 9 times 12 is 108. And if I add up 12 plus 60 plus 108 together, I would have 180 degrees. Okay? I divided up the triangle angles into an extended ratio of 1:5:9. If I said it was in a ratio of 2, 3, 4, we would do the same thing. 2x plus 3x plus 4x has to equal 180. So we find the value of x, and then we would plug it in and be able to solve for the 3 different angles. Obviously, I have 3 different angles because it's a triangle with 3 angles. We will do the rest of this in class. As a quick recap, ratio is part to part, whereas scale factor is part to whole. If you're given the ratio, you can find the scale factor, such as here we divided up into a ratio, but here we had we divided the line into a scale factor. 3 parts over 8, because 3 plus 5 is 8. And then here they gave us a ratio of 1:5, and we wrote the scale factor of 1/6, because 1 plus 5 is 6. And then we did a couple of problems using this information. If you have any questions, please make sure that you are writing them down in your margins. And when I ask for questions next class, I will be happy to answer them. Have a great day, Wolfpack. See you next class.